We are still studying the problem of a firm that is trying to raise funding from outside investors under asymmetric information. Now we're going to take the perspective of a firm that knows its type. And now you should think about firm insiders. So that can be the firm's managers, entrepreneurs, that could even be the firm's current shareholders. So all these firm insiders that we're going to refer to collectively as the firm, they know the firm type. Okay, they have information about the type of the firm. And they are facing outside investors who can provide funding, but these outside investors do not know the type of the firm, so they are uninformed. Okay, and now we're going to try to understand how in this situation the firm will optimally raise funding, and when it will even go to outside investors for funding, as opposed to using self-financing. Okay. So this firm has some cash available, and this cash can be used to fund investments. And currently, to make things simple, it has no liabilities, so it doesn't owe anything to anyone. Now there's an investment opportunity, and the cost of the investment is capital I. And this is larger than A, so we know that the firm, whatever it's doing with its cash, regardless of that, it's going to need to raise external funding from outside investors who are uninformed. And this investment, so if you invest this amount I, you're going to invest in a project that's going to yield revenues RS following success and RF following failure. And obviously RS is greater than RF, and RF is still positive. Okay, and so what can the firm do? So the firm, first of all, is going to need to decide how much of its existing cash to invest in the project. And at most, it can invest all its cash in the project. And it can also invest none of its cash in the project or anything in between. Okay. Whatever it does not invest in the project, it is paid as dividend. So of course, if little a here is equal to capital A, the dividend is 0. You reinvest everything into the project, so you're not paying anything to your current shareholders. On the contrary, if A here is equal to 0, then you pay all your existing cash as a dividend to outside investors. Okay. Or anything in between again. So in any case, so whatever you do, you're going to need to raise funding from outside investors, even if you reinvest all the cash into the project. Okay. And how much funding do you need to raise? Well, you need the cost of the investment minus what you yourself reinvested. So this is what you're going to go to outside investors to obtain. Okay. So the summary, so you have an amount of cash A. You're going to reinvest little a out of this amount of cash, and you're going to pay this as dividend. Okay. And so now if you look at the firm's balance sheet, so this is going to be the firm liabilities, what it owes to outside investors. Now this is the amount that you raise from outside investors. And if you look at the firm's assets, well, they're going to be worth I. This is the cost of the investment. And of course, current shareholders, so they are going to own the firm assets minus the firm liabilities, and they're also going to receive this dividend. Okay, so what does it mean for the firm to be a good type? Well, so it's going to relate to the probability distribution over future revenues, so RS or RF. And so the probability of success depends on the firm type. And for a good firm, we're going to make things very simple here. We're going to assume that the probability of success is 1. Okay, so good firms are going to be successful. Good firms are going to produce revenues RS when they invest in this investment project. On the contrary, bad firms have a probability of success of 0, right? So they're always going to produce the revenues of RF following failure. Okay, and there's a proportion rho of good firms and a proportion 1 minus rho of bad firms. So why is this rho important here? Because investors do not know the firm type, and they do not know which firm they are facing, but they know that there's a proportion rho of good firms and a proportion 1 minus rho of bad firms. And so they're going to use that to form their expectations. And if you look at the expected probability of success across all firms, and this is called M, this is going to be equal to the proportion of good firms times the probability of success of a good firm, plus 1 minus rho times the probability of success of a bad firm. Okay, but here with our simple assumptions, P equal 1, Q equal to 0, this expected probability of success across all firms. So if you do not have any information about the firm you're facing, and given our assumptions, P equal 1, Q equal to 0, this whole expression here is simply equal to rho. Okay. So let's summarize what's going to happen. Also, what is going to be the contract that the firm is going to enter with its investor. So if you're a bad firm, and you're going to be successful with probability Q. So here Q is equal to 0, in which case you produce RS, and unsuccessful with probability 1 minus Q, in which case you produce RF. Likewise, for a good firm, you're successful with probability P. So here P is equal to 1, in which case you produce RS, and with probability 1 minus P, you are unsuccessful. Okay. At the contracting stage, so when the firm is going to enter a contract with its investors, the investors do not know the firm type, and the firm cannot credibly reveal its type, and because it's related to future revenues that the firm is going to produce. So the firm is going to enter into a contract with its investors. The contract is going to specify the payment to investors in the case of success or in the case of failure. And this is, of course, regardless of firm type, because the firm type is not known and it is not contractable. You cannot write it down in a contract. But what you can write down in a contract is the payment you're going to receive in case of success and in case of failure. And so here for the investor, the payment in case of success that the investor will receive is RIS, and the payment received by the investor in case of failure is RIF. And of course, again, because firm type is non-contractable, this contractual payment is the same regardless of firm type. Okay. So yeah, so the firm is going to get financing. It's going to raise external funding by issuing a security or several securities with a state contingent payoff. So what does this mean? It means that the payoff to the investor, the payment to the investor, is going to depend on the outcome, whether the firm is successful or not. And so the financing contract is fully described by these two values: the payment in case of success, RIS, and the payment to the investor in case of failure, RIF. Okay. What are we going to assume? Well, just to make things interesting, we're going to assume that the investment NPV is positive on average. So it means across all firms with M, which is equal to rho. Obviously, if the NPV were negative, then we would not want to invest in the project. So that would not be a very interesting problem to study. So we assume a positive NPV. So the expected revenues from the investment minus the investment cost. So this is positive. So there's a 0 discount rate. So there's no discounting to keep things simple. And so, yes, again, if we replace M by rho, that gives us this condition. This NPV is positive if this condition is satisfied. Also, we're going to rule out an uninteresting case, and so we'll get back to this assumption. So for now, we're going to assume that the revenues that the firm derives in case of failure are quite low. So it's going to again make the problem quite interesting. And in particular, they are lower than the investment of the outside investor in any case. So even if firm insiders are going to reinvest everything they can into the project. I minus A in this case would be the minimum investment of the outside investor. But even this minimum investment would be greater than the firm revenues in case of failure. Okay. And because capital A is larger than little a, and because RIF will be less than RF, there's limited liability, so you cannot pay more to investors than what the firm produces. So RIF is at most equal to RF. This condition here implies this one. Okay, so now let's solve the model. Okay, and we're going to start with so when we solve this type of model, there's often several conditions. There's going to be often a break-even condition or a market clearing condition, and there's going to be something that's related to optimizing behavior. Okay, so let's start with the break-even condition from the perspective of investors. So the firm is facing some competitive investors. They are risk neutral, and so they will fund the firm as long as their profits are non-negative. And so the firm, to extract as much money as possible from outside investors, is going to set their profits equal to 0. So the terms of the contract are going to be such that investors exactly break even in equilibrium. And here for now, we're going to consider a pooling equilibrium, meaning that investors do not know the firm type. And we're going to understand a bit later, so why this is going to be the equilibrium. Okay, so investors do not know which firm they are facing, right? They are uninformed, and the firm's actions do not reveal its type. So investors do not know the probability of success. The only thing they know is that the expected probability of success across all firms, which is M, in this case is equal to rho, right? And so in expectation, they know that if they fund the firm, given the contract that they have received, and given this contract, this is going to be their expected payoff. And this is the probability of success of the firm that they are funding. They do not know if they're funding a good firm or a bad firm. If the firm is successful, they're going to receive this much. This is the probability of failure of the firm they are funding, so from their perspective again. And this is the amount they receive in case of failure. And this term here, this is the amount that they are investing in the firm. Okay, so here's a break even if the amount that they are investing is equal to the expected revenues they will get. So I minus A, I get that from here. Okay, so now I'm just going to use M equal to rho. That's what I have here. And that's it for now. So I get this equation too. The second step is the optimizing behavior of the firm. So how is the firm going to design the contract and to choose its financing? So it's going to simply maximize its expected payoff. And so this is from the perspective of firm insiders, including current shareholders. So what is going to be the payoff they're going to receive? And so we're going to start with the perspective of a good firm. So for a good firm, because we made things as simple as possible, the probability of success for a good firm is P equal 1. Okay, so for a good firm, you are going to be successful with probability 1. You're going to produce revenues of RS, but you're going to need to pay RIS to your investors. Okay, so this is what goes to the firm's current shareholders. Firm shareholders are also going to receive the dividend, right? They're going to receive this amount as a dividend. Okay, so now let's rewrite this expression. This is what we do in equation 3 here. So this expression here, and how am I going to rewrite it? I'm going to rewrite it using this equilibrium break-even condition that I have in equation 2. So here I have RIS, the payment to investors in case of success, which is what investors in a good firm are going to get. I'm going to replace it by the expression that I get for RIS in equation 2. Okay, so I solve equation 2 for RIS, and I'm going to replace in here. Okay, and if I do that and I rearrange a bit, I'm going to get this equation 3. Okay, so try to do that at home. And if you rearrange the terms, you should be able to get this. And so remember, this is the payoff to shareholders in the good firm, net of what they have to repay to outside investors who on average break even. So they make 0 expected profit. So what is this payoff equal to? So it can be decomposed into 3 terms. The first one is simply the initial investment of the shareholders. This is the amount A that they reinvested. The second term here is the NPV of a good firm. So remember here, the shareholders are shareholders in a good firm. They know the firm type. So they know that the NPV of the investment, from their perspective, it costs R, is going to produce RS with probability 1. So the NPV is RS minus I. Okay. So if somehow there were no asymmetric information, if everyone knew that the firm had a good type, the shareholders in a good firm would get back whatever they invested, plus they will get the surplus, right? Because outside investors just break even. But this is not what's happening here, right? Because the payoff that they get, the shareholders in a good firm, so it's equal to this, but there's also this additional term. And so what is this? So this term is, so this whole thing here, including the minus sign, is negative. So it's going to lower the payoff to current shareholders in a good firm. And why is this? Why is this whole term negative? So this is because of the assumption that we made here that resulted in this. So this term in brackets here is positive because of this assumption. And so this whole term is negative. So it brings down the expected payoff to shareholders in a good firm. And we refer to that as the adverse selection discount. Now this is the price that current shareholders in a good firm are going to have to pay to raise external funding. This is a very important notion. External funding is costly to a good firm. And why is that? Well, first of all, as you can see, if rho were equal to 1, this whole term would be equal to 0. And this is what I told you before. If there were only good firms in the economy, so if there were no adverse selection problem, this whole adverse selection discount would be equal to 0. So why do we have an adverse selection discount if there are also bad firms in the economy? So if rho is less than 1. Well, it's all due to this break-even condition for investors, right? So the idea here is that because of this assumption that we made here that resulted in that, investors are always going to lose money when they invest in a bad firm, okay? Because the payment they're going to get is going to be less than what they invested when they fund a bad firm, okay? And this is reflected in in equation 2, right? But if that is the case, if they always lose money when they invest in a bad firm, well, to break even, they need to earn money. They need to make positive profits when they invest in a good firm. But if they make positive profits when they invest in a good firm, this is going to be at the expense of current shareholders in the good firm. Okay. And so this is why external finance is going to be costly for a good firm, because you need to pay outside investors a lot because of the adverse selection problem. So in other words, because outside investors might be funding a bad firm and lose money, when they fund any firm, when they don't know the type, they're going to need to make some positive profits when this firm's type turn out to be positive. And so this is going to be costly for the shareholders of a good firm, the current shareholders of a good firm. Okay, that's an important notion. Huh? So that gives rise to an adverse selection discount. So now let's understand, so what are shareholders in a good firm going to do? And essentially their problem is going to be to minimize this adverse selection discount. Okay, external finance is costly, but you can still, depending on the action that you take, minimize this cost. And how are they going to do that? Well, what shareholders in a good firm are going to try to do is that they're going to try to maximize this whole thing, right? This whole payoff that they are getting, including the dividend. Okay, and so bearing in mind that this is equal to that. So as you can see, whatever they're getting here as the dividend minus A is going to cancel out with A. So we don't need to take that into consideration. So the only thing they're going to try to do essentially is they're going to try to minimize the adverse selection discount. What does that involve? Well, first of all, as you can see, so there's one minus sign here. This is positive, another minus sign there. So it means that this whole term here is increasing in RIF, or equivalently, the adverse selection discount is decreasing in RIF. Okay, and so to maximize the expected payoff, so to maximize this, it is going to be optimal for the firm's shareholders to set RIF equal to RF. You want to maximize this expression, and this is achieved by setting RIF as high as possible. Okay, so meaning that if you fail, you're going to want this whole payoff to go to outside investors. And how can this be put in place? Well, we're going to see later that this can be implemented with debt funding. So this is the first recommendation. You're going to borrow, you're going to issue debt rather than equity. And we're going to get back to this point. For now, just remember that we have the payment to investors in case of failure, which is as high as possible, which is equal to the amount of revenues the firm generates in case of failure. When you fail, you give everything to investors. The second thing that you have to do is that, again, if you want to maximize this or equivalently minimize the adverse selection discount, as you can see, so you have two minus signs. And so this whole expression here is going to be increasing in little a. Okay, so again, you want to set little a as high as possible, and you're going to set it equal to capital A. What does this mean? Well, this is very straightforward. It means that you're going to use internal funding. You're going to use self-financing as much as possible. Remember, setting A equals to capital A means that you're going to reinvest your whole cash into the project, and you're going to reinvest as much as possible. And this implies also that you're going to pay a zero dividend. So you use internal funds to fund the project as much as possible. And so why is that the case? So what is the intuition behind these two results? Well, the idea is that if you use internal funds as much as possible, this is going to reduce your reliance on external funding. And the less you rely on external funding, the less costly it is going to be for you, because as we know, it is costly for a good firm to access external funding. Okay. What about this? Well, here this is a similar idea. And here this is not so much about reducing your reliance on external funding as it is about making external funding less costly. Because as you can see, when you set RIF as high as possible, this is going to reduce the losses that investors are going to have to bear when they invest in a bad firm. But so if they make lower losses when they invest in a bad firm, they're not going to need to be compensated as much when they invest in a good firm. And so increasing RIF allows you to reduce RIS in such a way that outside investors still break even. Okay, so these are two very important principles. Okay, so we have not fully solved the model yet. We're almost there. So we have determined RIF, and we have determined the amount of reinvestment. We still need to determine what RIS is going to be. But now this is very straightforward, right? Because we have determined RIF, and we have this equilibrium condition for investors to break even. So if we just replace RIF by RF in this equation, equation 2, we get this. And so if we just replace and we solve for RIS, we find that RIS is equal to this. And this whole term here, because of the assumptions that we made, this whole term here in yellow is positive. And so RIS is greater than RF. And so it means that the payment you're going to make to investors when you are successful is going to be greater than the payment you make to investors when you fail as a firm. Okay. Okay, so this is a pecking order theory. So the recommendations of the pecking order theory is that you want to maximize reinvestment in the firm to minimize your reliance on external funding from outside investors. And this is this principle. So yes, you want to minimize your liabilities. So the firm assets is going to look like this. As much as possible, you invest the own cash of the firm. And well, there's still going to be some liabilities because of the cost of the investment. Once you've done that, and so this implies a zero dividend payment. Once you've done that, if you still need to raise funding from external investors, you're going to use debt as much as possible. So here you're going to maximize the amount of debt funding. And if you still need to pay a bit more to outside investors because let's say you reach your maximum debt capacity, as a last resort, you're going to use equity. Okay. And so in this case, we're going to see the interpretation of equity. But if you interpret RF as the amount of debt that's going to be raised, as you can see, to get a payment of RIS, you still need to pay this much to outside investors in case of success, and that can be achieved by giving outside investors some equity in the firm. Now we're going to study that on the next slide. So what are some more implications of all this? Well, first of all, good firms are subsidizing bad firms because the payment to investors when the firm has a good type is going to be greater than the payment to investors when the firm has a bad type. And this follows from this equation. And there would not be any cross-subsidy across firms if the payments were the same in case of success and in case of failure. And it's going to be achieved in some cases. We're going to get back to this. This cannot be achieved if we make this assumption. Okay, so now let's try to understand how you can put in place this funding arrangement. So we want to have RIF equal to this and RIS equal to that. So how can you put that in place? I already mentioned debt and equity, but now let's be more precise about this. Okay, so you can put in place this contract by issuing two types of securities to outside investors. The first one will be debt, which in this case is going to be risk-free, with a repayment of D equal to RF. So why is it risk-free? Because any firm is going to produce at least RF. Okay. But this is not enough, right? We've seen that if we were to pay RF to outside investors would not break even. So you need to pay more than that. What can you do? Well, you can issue some equity to outside investors. And this is going to represent this fraction of total firm equity. So how do I get this lambda? Well, again, I need to make sure that investors break even. I know that they will not break even if I just issue debt. So I'm also going to give them some equity. How much equity do they need to get? Well, let's see. So if the firm invests as much in the project as possible, so little a is equal to capital A, this is the amount that outside investors are going to invest in the firm. So now let's look at what they're going to get back out of this investment. And again, this is the perspective of outside investors who do not know the firm type. So with probability rho, they'll be funding a good firm, and with probability 1 minus rho, they'll be funding a bad firm. Okay, if they're funding a good firm, so in any case, the firm issued debt with this repayment. Okay, so in any case, they're going to get debt. They're also going to get a fraction lambda. And for now, we just know that this is lambda. We don't yet know that it is equal to this. They're also going to get a fraction lambda of equity in the firm. What is the equity payoff for a good firm? Well, this is the revenues that the firm produces minus the repayment to debt holders. So this is the overall equity payoff for a good firm. And outside investors are going to get a fraction lambda of this. Let's look at the equity payoff for a bad firm. Well, the firm is going to produce RF. It's going to have to repay D to its debt holders. And outside investors get a fraction lambda of this. However, in this case, RF minus D is simply equal to 0 because the debt is set up this way. Okay. So even though outside investors get equity in any case, whatever the firm type, it turned out that equity in a bad firm will be eventually worth 0. Okay. And now what do we do? Well, this is an investor's break-even condition. So we're going to solve for the variable that we're interested in, which is lambda. Okay, so we solve this whole expression for lambda, bearing in mind that this is equal to RF minus D is equal to 0. And we find that lambda is equal to this. Okay. And so this is a fraction of equity that you're going to give to your outside investors. And so there's an interesting case, right? If we had that RF were equal to I minus A instead of less than I minus A, so if this were an equal sign here, as you can see, so RF is equal to D. So as you can see, this numerator would be 0. So you would not need to give any equity to your outside investors. And why is that? Well, this is because simply by issuing risk-free debt with this repayment, so RIF will be equal to RF, and RIS will be equal to RF as well. And little a would be equal to capital A. In this case, investors would break even only with debt financing, okay? And so in this case, there would not be any cross-subsidy across firms. We would have this equality. And so it is only when bad firms are sufficiently bad and when your investment needs are sufficiently large that there is going to be a cost to external funding. And this is because in this case, the adverse selection problem is going to be sufficiently severe. You need a sufficiently large amount of money and bad firms are sufficiently bad. So then there's going to be a positive adverse selection discount. Okay, we're almost done. One thing we still have to verify is, so we assume that there would be a pooling equilibrium at the beginning. So why is that? So let's consider the perspective of a bad firm. Earlier, we considered the perspective of a good firm. So let's consider a bad firm. So one thing it can do is it's going to imitate whatever a good firm will do. So this involves what we derived here. And so then a bad firm would do likewise. And it would issue the same fraction of equity as a good firm, this fraction of equity. So it takes the same exact actions as a good firm. So what happens then? Investors are going to invest, exposed, they get a negative return, even though ex ante it would be indifferent between investing and not investing. They get a negative return because the amount that they invested is greater than D, which is also RF in this case. And so the firm is going to pay all its output to investors. So D is equal to RF. So all of the firm revenues go to outside investors. This is a pooling equilibrium because ex ante, all firms are going to take the same actions. All firms are going to reinvest the same amount. They're going to issue the same securities, debt, and equity. And so investors will not be able to tell these firms apart. And because of that, there will be a pooling equilibrium. But then you may say, okay, but then the firm and its current shareholders are not doing very well because then they're going to pay all the output to outside investors. So maybe it could do something different. Maybe it should not set RIF equals to RF. Maybe it should reinvest less in the firm. So what do you think? What would happen in this case if a bad firm were to act differently from a good firm? Well, in this case, investors would be able to identify a bad firm. They would know because of its actions. The firm's actions will reveal its type. And then because investors always make a negative return when they invest in a bad firm, they would never agree to invest in a bad firm in the first place. Okay, so that doesn't work for a bad firm. So the best thing that a bad firm can do is that it can imitate whatever a good firm is doing. Okay, and that gives rise to a pooling equilibrium in which investors cannot tell firms apart. Okay, and then there's this an interesting case with RF, which is greater than the amount that investors will invest in the firm. So again, we already discussed that. So in this case, we would set D equals to actually to I minus A, which is less than RF. And so the firms would not need to issue any equity and there would not be any adverse selection discount because we would have that the payment to investors in case of success would be equal to the payment to investors in case of failure. It would be equal to I minus A in both cases. Okay, so that's a bit less interesting, but it could still be a relevant case, right? It's just that in this case, external finance would not be costly. Okay, so let's summarize. We're done with the model. So for good quality firm, external finance is costly, and this is because of adverse selection, because investors cannot tell apart good firms from bad firms at the time when they are investing their money, at the time when they are providing funding to the firm. And so because of the cross-subsidy, bad firms exert a negative externality on good firms. Because again, investors are making losses when they invest in a bad firm, and so they must make profits when they invest in a good firm to break even. But investor profits will be losses from the perspective of the firm's current shareholders, right? Then external funding is going to be costly. So how can you minimize this cost of external funding? Well, this is minimized when you minimize the amount of external funding required, which is achieved by using internal funds as much as possible, or self-financing. Okay. When despite self-financing, outside funding is still required because the cost of the investment is sufficiently large that the firm cannot self-finance everything. Again, the principle is to minimize the adverse selection discount, which is achieved by primarily issuing securities whose value is not very sensitive to the type of the firm. And so what are these securities? Typically, they will be debt securities. Okay, so payoff of debt is not very sensitive to the firm type. In the case when it's risk-free debt, then it is not at all sensitive to the firm type. Okay, and so this is a type of security for which the adverse selection discount would be 0. On the contrary, equity is a very information-sensitive security in the sense that the value of equity depends a lot on the type of the firm. So you're going to only issue equity as a last resort when you've exhausted your debt capacity, and yet you still need to pay more to outside investors in expectation in order to ensure participation from outside investors. Okay, so this is a pecking order theory. So the pecking order for firms when they are trying to get funding for their project is, first of all, you rely on internal funds. Second, you are going to issue some debt, starting with risk-free debt. And then if this is not sufficient, you're going to issue some more information-sensitive securities, for example, more junior debt or even equity. Okay, so equity will be the last resort. Okay, so one last thing that you might be wondering is what happens when some investors are informed? As we studied, for example, in the Grossman-Stiglitz model, it's reasonable to assume that on financial markets, some investors will be more informed than others, right? Here in this model, the assumption that we made was that firm insiders, so the current shareholders, the current managers of the firm are informed, but outside investors are uninformed. So what happens when some outside investors are also informed and others are not? Well, this is a model of Booth and Tucker in the JF 1993. And in this case, what the firm is going to do is that it's going to partition its cash flows into 2 securities. And one security will be non-sensitive to information. And this is consistent with prediction of the pecking order theory. When you're facing uninformed investors, you should have a security which is as close to risk-free debt as possible. and the security will be bought by uninformed investors. But then you also want to have a security whose value is sensitive to the firm type, which is going to be bought by informed investors. But then, whereas in the pecking order theory model, you would face a heavy adverse selection discount by issuing such a security, in this model with informed outside investors, that would not be the case. And this is precisely because outside investors are informed, and so they can tell when a good firm is issuing the securities or when a bad firm is issuing the securities. And precisely because they are informed, they can offer good terms to good firms. Okay, so this is also an interesting model, but we're not going to study it this week. Okay, so you should try to read the corresponding chapter in the Tyrol textbook. And there's also some exercises for you to do. Okay, that's all for now. Thank you.